Hello, so this is our CS225 final project presentation. Our group members here are Jiale Lin, Jiahe Su, Qingwen Zhou, and Shumin Su. Our data is from a website called openfly.org. There are mainly three parts of our project. The first of all are the traversals, both breadth first search and depth first search. And the second part is a Dijkstra's shortest path. And the third part is a graphic output of the graph. So as I said, our data is from the openfly.org, and we mainly used two files from the website. First of all is a file called airport.data. It contains things like airport.id, IATA, ICAO, latitude, longitude, many others. And the second file is called route.data. It contains things like airline ID, source airports, its ID, destination airport, its ID, and many others. So in the first step, we changed those parameters into vectors in a way to let our teammates to build in other algorithms. So the way we calculate the distance between the two airports is through a formula called the Haversine formula, where phi is latitude, lambda is longitude, and r is the Earth's radius. Shumin Song will start to talk about next how did he implement the traversals inside this project.
Hi, I'm Shumi-san. I'm going to introduce the traversals method and the construction of directed weighted graph in our program. In our graph construction process, we used adjacency matrix to represent the graph. We also set the airports as the vertices, the flight routes as the edges connect the vertices, and the distance as the edge weight. We also designed a print function to print the adjacency matrix in order to visualize the graph. For the traversals methods, we use both BFS and DFS methods. BFS is used as the major method. We designed this function taking the assigned airport as route vertex to traverse all the airports where the source airport could visit. According to the breadth first search order, the BFS function traversed the airports that could be directly visited from the starting airport at first, then traversed the airport that could be accessed via other airports from the starting airport. We also use DFS traversal function as the supplemental methods. It takes the assigned source airport as route vertex and vector of Boolean to keep track of the visited airports. It can show particular routes to destination airports and specify transfer airports in the routes. Thus, it can compare the complexity between different routes to the same destination. The more complex route has more transferable stations in the route. Since we want to avoid these complex routes, we can use BFS and DFS methods to help us to get a better understanding, to get a better idea which route is shorter. But we cannot get accurately which route is the shortest. Then we need to design Dijkstra algorithm to help us figure out the shortest path between two different airports. In the next part, my teammate Jiale Lin will introduce how he designed and implemented Dijkstra algorithm to find the shortest path.
Thank you, Su-Ming. I'm Jiale. I'm going to introduce the Dijkstra shortest path. The first step will be generate new vectors contain direct distance from source to all airports from adjacent matrix. Then the following code will repeat n times. The step 2 will be loop through all unvisited vertex. Then get the minimum weight of the source to unvisited vertex. Then this minimum weight will be recorded in the distance transit dot values. The index of transit airport will be stored as a t, and the transit airport will be set as visited. Then we will visit all unvisited neighbors of transit airport if the distance t dot value plus the distance from transit airport to neighbors is less than the distance from source to neighbors, we'll update new distance. In the meantime, we'll update the new path. The new path will be source to transit airport to neighbors. The running time in big O will be n squared. Then two small sample airport and the logs will apply in the code first and verify the printed path with the actual path. The code will run with all airports and logs and the store result in the pass out TST. Here's the sum of the output. If we set the start of the airport will be YFB, the minimum path will be flowing. Then Qingwen will introduce the graphic output of the graph.
Hello everyone, this is Qingwen. Now I'm going to present the third part of our project doing the graphic output of the graph. So the goal of this part is to project the shortest path from the target airport to the other airports to a world map. And as we know, using digestion algorithms, we have already produced the shortest paths for any two given airports in the previous slides. So in this step, in the following step, the user can select a target airport by inputting the corresponding IATA. For example, in this case, we input PVG, which is Puto International Airport. And next step, given this target port, we're using like the digestion algorithm, we get the shortest path from the target airport to all the other airports. So see the example here, we can see the shortest path between PVG to JKA and PVG to MAG, and all the other will be all the information will be listed in the path out txt. And next step, using this this minimum path information, we can get a repetition matrix, which is give for any two airport in the shortest path, we can find if there is a connection between these two airport, we add the repetition by 1, increase the repetitions by 1. If another shortest path also included the connection between airport I to airport J, we will also increase the repetition by 1. And then finally, we can get this repetition matrix. And so also for the next step is to get the corresponding longitudinal and the latitude of airport I and J per show in this repetition matrix. So we have this longitudinal and the latitude of airport I and airport J, and then convert them to a corresponding pixel location in a 2000 by 10,000 or 2000 by 1000 pixel map. And this size is based on the input map we provided, and then using these functions, we can convert the longitudinal of airport I to a location xi of which is the horizontal location of airport I in this map, and the latitude I we can convert to a vertical location to this pixel map. And finally, we're using xi, yi, xj, yj. We can connect a straight line between these two airport I and j. And then we mark all the pixels on this straight line to a different color. So we change the pixels on this straight line to color yellow, which is h equals 45, and we set L equal to 0.5, the A equal to 1, and S equal to 0.6 plus 0.01 times the repetition of I and J. It means if we have more have more repetitions between airport I and airport J, we will minorly increase the saturation of this flight. And finally, here is an example output. We select PVG as a target output airport, and then we produce this graphic output. Thank you for your listening and let us know if you have any questions. Thank you.